start section 8.2 today, which is exponent properties with quotients. Yesterday we talked about exponent properties with products, and today we're going to discuss quotients, which quotients means that we are dividing. Yesterday we were multiplying, today we're dividing. So I want you to notice something here. We have a to the fifth divided by a cubed. Okay, using our exponents, we know that a to the fifth is a times a times a times a times a. And a to the third is a times a times a. Well, we can use division because we know that a divided by a, any number divided by itself is 1. So we can just go ahead and cancel out all of these versions of 1 because anything times 1 is itself. Okay, so all those become 1, and then we're left with a times a, which is a squared. Which, if you look back at the original problem, 5 and 3, the relationship there, 5 minus 3 equals 2. Okay, so yesterday, when we were multiplying, we were adding exponents. Today, when we're dividing things with the same base, we can just subtract their exponents. And that is the quotient of powers property. Okay, if we let a and b be non-zero real numbers, and m and n be positive integers such that m is bigger than n, so the exponent's bigger on the top as it is on the bottom, then we keep the base again, that's very important, base stays the same, and then subtract the exponents. So here we have a to the m divided by a to the n, and we get a to the m minus n. A can't be 0 because we can't divide by 0. Over here with numbers, we have 4 to the 7th divided by 4 to the 2nd. Notice, we keep the base, so we keep 4, and then we subtract 7 minus 2, which gives us 4 to the 5th. Okay? So, let's try a few examples. Here with example number 1, we have 8 to the 10th divided by 8 to the 4th. Okay, those have the same bases, which means that we can use our quotient of powers property. So we're just going to go ahead and keep our base, which is 8, and then we're going to subtract the exponents. So we have 10 minus 4, okay? Which 10 minus 4 is going to give us 8 to the 6th power, and that would be your answer. Okay? Example 2, remember we talked about the importance of parentheses yesterday. We have negative 4 to the 9th and negative 4 squared. We're dividing those two. So if we're dividing things with the same base, that means we can keep our base. So we're going to keep negative 4 and then take 9 minus 2, which gives us negative 4 to the 7th power. Okay? Here we're going to apply a property that we learned yesterday along with the property that we are learning right now. So here we have 9 to the 4th times 9 to the 3rd, all divided by 9 squared. Okay, so yesterday we had this product property where when we multiply things with the same base, we can add their exponents. So in the top, we're going to keep our base and then add our 4 plus 3. And then we're dividing that by 9 squared. So that's going to give us 9 to the 7th divided by 9 squared, because 4 plus 3 is 7. Okay, now we're going to use our quotient rule to finish this problem. We're going to keep our base again, but now we're going to subtract the exponents. So we have 9 to the 7th minus 2, which gives you 9 to the 5th. And that is your final answer. Okay? Down here, we have fractions, which I know you all love fractions. 1 over y to the 3rd times y to the 8th. So here we're going to see this y to the 8th over 1. When we multiply fractions, we multiply our numerators. So 1 times y to the 8th is y to the 8th, divided by, we multiply your denominators. Y cubed times 1, which is y cubed. Okay, and now we just have our quotient of powers property. So we're going to keep our base, 8 minus 3, which is going to give you y to the 5th power. Okay? And that is our quotient of powers property. The second and last property that we're going to talk about today is the power of of a quotient property, which is going to be very similar to the power of a product property that we talked about yesterday. So I want you to notice again, here we have a divided by b to the fourth power. And we know whenever we take something to a power, that is the number of times that we multiply itself. Okay, so if we have a divided by b to the fourth power, that means we're going to take a divided by b and multiply it 4 times. So a divided by b times a divided by b times a divided by b times a divided by b. Okay? Like we talked about yesterday, you can multiply and divide in any order that you want. So what we're going to go ahead and do is multiply all of our a's together and all of our b's together and then divide them. So we're going to have a times a times a times a divided by b times b times b times b. Which a times a times a times a is a to the fourth, and in our denominator we have b to the fourth. So notice what we started with, a divided by b to the fourth becomes a to the fourth divided by b to the fourth. Okay? This is called our power of a quotient property. So you're going to find the power of the numerator and find the power of the denominator, and then you divide them both. Okay? So here we have a divided by b to the m. We're just going to take a to the m divided by b to the m. And again, b can't be 0 because we cannot divide by 0. Okay, so if we have 3 halves to the 7th power, we take 3 to the 7th divided by 2 to the 7th. Okay? Alright, so over here, we have a squared divided by b to the 5th. Okay, so using our power of a quotient property, we're going to take our numerator to the 5th and take our denominator to the 5th. So we are going to have a squared to the 5th power divided by b to the 5th. Okay, using our power of a power property from yesterday, whenever we have something to the power, we can just multiply those two together. So we're going to have a to the 2 times 5, which is going to give us a to the 10th divided by b to the 5th. Now, notice, we are done here because these have different bases. So we cannot subtract those exponents because these are different bases. If they were the same base, then we could continue and simplify. But because the bases are different, this is as simplified as we are going to get. Okay? Our next example, we have negative 5 divided by y. So we are going to take our negative 5 and our y, and we're going to cube the numerator and cube the denominator. So we're going to have negative 5 cubed divided by y cubed. Negative 5 cubed is negative 5 times negative 5 is positive 25 times negative 5, negative 125 over y cubed. Okay? And that one is done. Alright, example 3, we are going to apply a few more properties. So we have x squared divided by 4y, all squared. So we're going to use our power of a quotient and square our numerator and denominator. So we're going to have x squared squared divided by 4y squared. Okay, so right here we're going to apply the property of our power to a power. So we're going to go ahead and multiply those two together. So x to the 2 times 2 is going to give us x to the 4th. And down here, we're going to use our power of a product property from yesterday, where we apply the exponent to each factor. So we're going to go ahead and square the 4 and square the y. Okay, so 4 squared, we're going to have 4 squared times y squared, which that simplified is going to be x to the 4th divided by 4 squared is 16, and we have y squared. All those are different bases. We cannot simplify any further. Done. Okay? And now our very last example looks a little complex, but we're just going to take it step by step. Might run out of space, we'll see. Okay, so if we take this cube, let's go ahead and distribute this cube using our power of a quotient property. So we're going to cube the numerator and cube the denominator. So that is going to give us 2s cubed divided by 3t cubed times t to the fifth over 16. Okay? From here, we're going to use our power of a product property, and we are going to cube each factor. So we're going to cube the 2 and cube the s, and then we're going to cube the 3 and cube the t. So we're going to have 2 cubed times s cubed all over 3 cubed times t cubed times t to the fifth over 16. Alright. We are going to put all of those under one square root, or not square root, excuse me, into one fraction. So we are going to take 2 cubed, 2 times 2 times 2 is 8, times s cubed times t to the fifth, all over 3 cubed is 27, and then we have t cubed times 16. Okay? So from here, we need to look for bases that are the same. Okay? So here, if we look closely, we have these t's that are going to be the same, and we're going to want to use our quotient property that we have just learned. Okay? Let me erase this. So coming up here, if we use our property, we're going to subtract the exponents. So t to the fifth and t to the third is going to give us 8s cubed. T to the 5 minus 3 is t squared, all over 27 times 16. I'm going to go ahead and reduce 8/16 to 1/2. So I'm going to have s cubed t squared over 27 times 2, which gives us the final answer of s cubed t squared over 54. Okay? And you cannot simplify any further because all the bases are different. And that is section 8.2.